Class, you should have already seen this video. It was online when it was supposed to be, but then it disappeared somehow from the internet. I'm going to go ahead and go through it again. That way I'll have a complete archive and you'll be able to refer to it for your second test. Okay, so what we're studying is how we can use normal distributions to model populations. And the population that we're going to consider was introduced in the previous video, 2A. So X denotes height in inches of college-age women. We're considering that population. We can model it with a normal distribution, that's what ND means, with mean 64.5 and standard deviation 2.5. So here I've shown you the probability density function for this population. It's of course a normal curve. The mean is 64.5. When we add a standard deviation, we're at 67, and that's one of the points of inflection, you remember. We go from bending down to bending up. When we add 2 standard deviations, we're at 69.5. When we subtract a standard deviation, mu minus sigma, we're at 62. Okay, now parallel to the x-axis, I've drawn the z-axis. This is the standard normal random variable. The value of z just tells us the distance from the mean to the x value measured in standard deviation units. So for instance, 69.5, the distance from the mean is 5, and a standard deviation is 2.5. So it's 2 standard deviations from the mean to this x value. For 62, we're moving to the left, so 1 standard deviation in the negative direction, so the z there would be -1. Now there's a simple formula for converting x values to z values, You subtract the mean from the x value and divide by the standard deviation. I just went through this example. When x is 69.5, what would z equal? 69.5 minus 64.5 is 5, divide by 2.5 and you get 2. Okay, now we're going to do a couple of problems. So the first one is problem 1. Find the percent of the population that is between let's see what numbers I used before. 62 and 68 inches tall. All right, here's the solution. So step 1, convert the x values to z values. Okay, so 68 minus 64.5 is one of them. Over 2.5 is one of the z values. So that's 3.5 over 2.5, which is 1.4. And the other z value we already had on the, I showed it earlier. 62 minus 64 and a half over 2 and a half is negative 1. Okay, so our z-values are negative 1 and positive 1.4. Now step 2. So we're trying to find this probability. Let's see, I have this backwards here. (62 to 68), excuse me. It's the same as the probability that z is from here to here. And now we do what we've been doing for a week now or longer. We use our standard normal distribution area table. So we have a z-value that's negative and a z-value that's positive. You remember how that works? We find the area from negative 1 to 0, and then we find the area from 0 to 1.4. Both of these areas are positive numbers. So for the first area, we get this. And for the second one, we get this. And they add to 0.7605. And then we read the problem carefully, and it asks for a percent. So 100% times 0.7605 is about 76%. Okay, so about, according to our model, about 70% of the concerned population is between this tall and this tall. It's a good idea to round off because these models are never terribly accurate. So round off to a couple of decimal places and hope for the best. Okay, problem 2. So we pose the following data. Your college roommate, your female roommate, is 71.5 inches tall. What percent of the college female population is taller than she is? Okay, so here's the solution. Step 1. So we need the z-value. Oh, wait a minute. 71.5 is 71.5, so that's our x value. So the z-value is 71.5 minus 64.5 over 2.5. And that is, as I recall, 2.8. So now step 2, you use the standard normal distribution area table like this. So the probability that x is greater than 71.5 is the same as the probability that z is greater than 2.8. Doesn't matter whether you say greater or greater than or equal to, the answers are the same. That may seem surprising, but it's true mathematically. Okay, so we have a tail here, right? So we now you have to go back to the normal distributions 1 video. So we subtract from a half the probability that z is between 0 and 2.8. Okay, so 0.5000 minus 0.4974, almost equal to 5000. So that's 0.0026. So this is step 3. The percent is, I'm running out of space here. So 100% times 0.0026 is about 1/4 of 1%. 0.0025 would be 1/4 of 1%. Okay, so I'm trying to stress here that you don't want to put too much reliability on the answer being very, very accurate. It won't. It typically is not. This is down at the very bottom of the screen, so I'm going to read what it says here. 100% times 0.0026, that's close to 0.0025, which is about 1/4 of 1%. I doubt you can read this. Let me read it to you. About 1/4 of 1%. Okay, so if your roommate were in a ballroom or a lecture room that had 100 female college students, she would most likely be the tallest person in the room. Okay, now you're going to have to do these kinds of calculations on your second test, but the distribution that you'll work with is the IQ distribution. So you'll have a different value of mu and sigma, but the method is exactly as I've shown you here. Good luck on your test, class.